everyone, here's a quick video on the transformations of rational functions. So the general form of a rational function is f of x equals plus or minus a divided by x minus h plus k. So again, the negative in front of the a is going to tell you if it's going to reflect across the x-axis. So that's stuff that is the exact same as we've learned all year long. Alright, the a is going to be your vertical stretch if a is greater than 1, or compress if a is between 0 and 1. Then x minus h, the h is still your left and right movement. If it's minus h, it's going to go to the right. If it's plus h, it's going to go to the left. Because remember, h is always the opposite of what you think. Okay, the k is going to still be your shift up and down. So plus k, it's going to go up. Minus k, it's going to go down. So it's the exact same as what you think because it's on the outside. So that's your over. Alright, the characteristics of the rational function. So this one has a vertical asymptote at x equals h. So the domain is x such that x does not equal h. So in other words, what this is saying is that we're having a party. And in our party, only one person can't show up. So everyone else is going to show up to the party except for that person. Or you can think of it as a puddle. So say I'm walking on a sidewalk, there's a puddle, I have to walk all the way to the puddle, then jump over the puddle and start back up. So whenever I write my domain, it's always going to start at negative infinity. It's going to go to my h, use parentheses to close it. Then I'm going to use a union. Alright, my kids, I'm requiring you to use the union. I know some teachers are letting you say all values except for this. That's totally cool too, but not for my students. Alright, so negative infinity to h, union, h to infinity. Okay? And that's the way that I'm going to write it throughout this entire video. Okay, the horizontal asymptote is y equals k. So the range is y such that y doesn't equal k. So again, it's like everyone's invited to the party except for k. So our range is going to go from negative infinity to k, union, k to infinity. Alright, the last main characteristic is that the parent function is y equals 1 over x, and the graph looks like the ones provided for you. So 1 over x, the h is 0, so that means we have an asymptote at x equals 0, so that's this right here. Alright, and then our k, there's nothing there, so it's plus 0, so our k is, or our horizontal asymptote, is at y equals 0. So right there's our asymptotes. So they're going to approach both of these asymptotes, but they're not ever going to touch them. Okay, so here that is the characteristics. Now we're going to go through some examples. Alright, so we're going to state that the HK, vertical asymptote, horizontal asymptote, transformation, domain, range, and I'll show you the graphs. So the first one, y equals 1 over x plus 2. This one, our h is plus, or in our formula it's plus 2, but it's opposite of what we think. So it's going to be a negative 2. Then I don't have anything added right here. So it's automatically 0. So our k is 0. So our vertical asymptote, it's always x equals h. So x equals negative 2. Our horizontal asymptote is always y equals k. So y equals 0. So the transformation, so looking at the HK, for starters, I moved it left 2. And I didn't move up or down. Now looking at, see if there's a positive or negative. There's no negative, so there's no reflection. And then we have it as 1, so it's like the parent function, so there's no stretch or compress. Alright, domain. I'm going to go from negative infinity to my h, so the negative 2, union, negative 2 to infinity. And then my range. I'm going to have every single y value except for my k. So I'm going to go from negative infinity to my k, which is 0, union 0 to infinity. Okay? Then when you look at the graph, it looks like this. So I moved it from the blue, which is the parent, to the red. Now as you can see, I have an asymptote at x equals negative 2. That's the dotted line that's provided. And also at y equals 0, which is the x-axis. Alright, next example. I got 1 over x minus 3. My h, there's nothing with my x, so it's automatically 0. That looks like a 6. Now it's like a 0. You're welcome. Alright, so 0. My k is a number on the outside, so negative 3. Vertical asymptote is always x equals h, so x equals 0. Horizontal asymptote, y equals k, so y equals negative 3. hk for my transformation. I did not shift it left or right, but I did move down. If I could write, I moved down 3. Okay, and I did not stretch or compress, and I did not flip it. Alright, domain. Every single x value is going to be included except for my h. So I'm going to go from negative infinity to my h, which is 0, union 0 to infinity. Alright, my range is going to have every single y value except for my k. So I'm going to go from negative infinity to negative 3, union, that looks like a 2, okay, union negative 3 to infinity. Alright, and then the graph will look like this. Okay, so I moved it from the blue, which is the parent, to the red. So as you can see, there's a horizontal asymptote at y equals negative 3, which is something that we excluded from our domain, our range, sorry. And then there's a horizontal asymptote at x equals 0, so the y-axis. Okay, if you have any questions so far, go ahead and stop the video, re-watch it, because these are the most basic examples that you can have. Alright, next one. We're going to state the vertical and horizontal asymptote, the transformation, domain and range, and all that fun stuff. Alright, so we have y equals negative 1 divided by x plus 3 minus 2. Alright, first thing I want you to do is state your hk. So my h, opposite of positive 3 is negative 3, and then I have a negative 2. Alright, for my hk, I can go ahead and state my asymptotes. So vertical asymptote is x equals h, so x equals negative 3. Horizontal, y equals k, so y equals negative 2. Alright, I'm going to skip the transformations right now. I will come back to it. My domain, it's going to have every single x value except for negative 3. So I'm going to go from negative infinity to negative 3, union negative 3 to infinity. Alright, now my range. My range is going to have every single y value except for negative 2. So negative infinity to negative 2, union negative 2 to infinity. Okay, now let's look at our transformations. So this one, the first thing I want to look at is this negative right here. The negative is going to reflect it over the x-axis. That's the first thing. Alright, I still have a 1, so I'm not stretching or compressing. Now let's look at the h. I have plus 3, so instead of moving to the right, which is what you think, I'm going to move to the left. So I'm moving left 3, and then add -2 on the outside, so it's exactly what you think. So down 2. Alright, so when you look at the graph, it looks like this. So if I had the parent function graphed, which would look something, I'm going to graph it in purple, it would look like something sort of like this, not really, but you get the picture. Whenever I reflect it, I literally just take my two functions and flip them over the x-axis. So instead of it going low-high, it goes high-low. Some kids in my class are wondering like what exactly the HK tells you, or how to tell what the transformation is based off the HK. So say you have your graph, your HK is where your two asymptotes intersect. So that's where that comes from. The stretch or compress, you're just going to have to look at it and try to figure it out. For some of them, I would just pick a point and plug it in. But yeah. So we have some application problems. So band members of a high school band plan to play at a college bowl game. The trip will cost $350 per band member plus a $2,000 deposit. Okay, a lot of y'all might be sitting there thinking like, oh, $2,000, that's a lot. Well, $2,000 is what the entire band has to pay, not just one person. Alright, so I want to write a function to represent the total average cost of the trip per band member. So I want to figure out how much one person is going to pay. So I'm going to call this f of x. For starters, we know one person has to pay $350. So I'm going to have a plus $350. Alright, the next thing is I have $2,000. I want to take $2,000 and divide it evenly among everybody in the band. So I'm going to have 2,000 divided by x, which is the numbers in the band. And this is how much one person will have to pay in order to go on this trip. Okay, big ol' hint when you write this stuff, like write your functions, it has to be a rational function because hint, hint, that's what we're learning about. Alright, next one. Find the total average cost per person if 40 band members attend the bowl game. So I'm going to take 40, plug it in for x. So when I do this, I'm going to have f of 40, which equals 2,000 divided by 40 plus 350. From there, type that in your calculator, and then you get $400. So each band member has to pay $400 if there's 40 band members in the band. If you have any questions on that, stop it, pause it, rewind, go back through. Alright, I have like 2 minutes to get you through this example. Alright, so the average cost per DVD purchase from the movie club, whatever, it's on the right, you got a table. The first question, I'm going to skip C and go down to B. The function that describes the data in the table has the form f of x equals 40 divided by x plus k, where k is a constant. What's the value of k? So the cool thing is, in the table, they gave you a bunch of xy values. So you can take those xy values and plug them in to figure out what your k is. So I'm going to use this one right here. I'm going to use 1 and 55. Alright, 1 is my x, 55 is my y. So that means 55 is f of x. So 55 equals 40 divided by 1 plus k. What is 40 divided by 1, you might ask? Okay, it's 40. So we have 40 plus k. Alright, solving for k, subtract 40. So k equals 15. Whoop, I don't know what my computer's doing. But, okay, so k equals 15. So I can take this now and plug it in right there. Alright, got 30 seconds. What's the total cost of buying 15 DVDs from the club? So for starters, I need to figure out the average cost per DVD. So I'm going to take 15, plug it in for x. So f of 15 equals 40 divided by 15, because that's your x, plus our k, which we found to be 15. Let me type this in the calculator. Sorry, I have 8 seconds. It's 17.6. Then to figure out the total cost, gotta multiply the whole thing by 15.